Let's imagine the speed of light is only about 1 meter per second. If I stood a reasonable distance away from you and moved at 90 degrees across your field of view, time for me would appear to slow down. At 95% the speed of light, the Lorentz factor is 3.2. So if I walked at 95% the speed of light across your field of view, time for me would appear to go 3.2 times more slowly. The problem with introductory textbooks on relativity is they don't take into account the fact that it takes light some time to get to you. As a consequence, what you see depends on whether the object is coming towards you or moving away from you. I want you to imagine that I can walk at 95% the speed of light. And I'm going to walk from here up towards you. And as I start, a photon of light leaves the tip of my nose. It's travelling at the speed of light. And so, as we both come towards you, in your frame of reference, the photon gets ahead of me. And by the time we get up close enough, we've covered 10 meters, and the photon of light hits you in the eye, travelling at 95% the speed of light, I am now only half a meter away. However, you have just seen light that left me when I was 10 meters away. So I look like I am a lot further away than I really am. So even though I am up very close to you, I look like I am way back here. Now, to travel that extra half a meter doesn't take me very long at all until I can get close enough and we can touch and rub noses. As a consequence, in that very short amount of time, the image of me, or what you see, is from me going right out here up to touching noses with you. So it looks like I am travelling many times faster than the speed of light. In fact, when we go through the calculations, you will find that even though I am only travelling at 95% the speed of light, I will look like I am travelling at 19 times the speed of light. An additional effect is that when you see me a long way away, you're also seeing me in the past. And so as I come towards you, I get more into your present. And so you will see a speed up effect with my time. By way of example, if I started off a distance of say 200 light minutes away from you, and I appeared to come towards you at 19 times the speed of light, it would only take me 10.5 minutes to get to you. So you would see me go from 200 minutes in the past to 10.5 minutes in the future. You would see in your frame of reference me experience 210.5 minutes of time. But you would see that happen in only 10.5 minutes. In fact, there's a speed up effect there of a factor of 20. Time will appear to go 20 times more quickly. However, we still have to remember time dilation. At 95% the speed of light, the Lorentz factor is about 3.2. So that's a slowdown effect of 3.2 times. 20 divided by 3.2 is about 6.2. So the net effect is, as I'm approaching you, not only will I look like I'm travelling at 19 times the speed of light, but time for me will appear to be passing 6.2 times more quickly. We get the opposite effect when an object is moving away from you. You see light that leaves it, and by the time that light gets to you, the object has moved further away. As a consequence, it looks like it is travelling more slowly than it really is. There is also a slowdown effect for time as well. If an object is moving away from you at 95% the speed of light, this slowdown factor is 1.95. So, we must also remember time dilation. The Lorentz factor is still 3.2, so 1.95 times 3.2 is about 6.2. So an object moving away from you at 95% the speed of light only looks like it's travelling at about half the speed of light, or just under half the speed of light, and time on that object appears to be going 6.2 times more slowly.